Hey folks, so welcome to the second level of SAT service challenges. In the first part, we solved a couple of problems from easy level and medium level, and we had stopped at problem number 8. So we'll continue from there. This is about the Nginx server which is broken, and on port 80, localhost port 80, it's giving a connection refuse. So our job is to fix it, and so that we can see the default Nginx page. So while the server is being spawned, we can just take a few guesses or hints about how to approach this problem. The first immediate hint to me is systemd, because they specifically mentioned that, and since we are getting connection refused, that means the server might not be running. So when we do a systemctl status nginx, we'll know why it's not running, and from there on we can further dissect into what the actual issue or problem is, and we go about solving that. It's taking a bit of time to spawn that server. It's ready. Yeah. So right off the bat, we'll do systemctl status nginx. Okay, you can see there's an unexpected semicolon in sites enabled config somewhere in the default configuration. Basically, line number 1, there's an unexpected semicolon. Another way to test any kind of configuration errors is sudo nginx-t, which also says the same thing. So we need to edit this, but I think this is a symlink, so it's better if we edit the actual file. Sorry, yeah, this points to sites available, and we'll edit that. The first line contains the semicolon, we'll remove it. We'll test our configuration, it's correct. So we'll just do a restart of nginx. This works. Journal ctl-u nginx-f. It started. So now I think localhost 80 should just normally work. It works, but we are getting a 500 error. To fix this, we can just check var log nginx tail the error logs, or we'll just tail all logs. Okay, interesting. We are seeing too many open files over here. Okay, this is related to a sysctl limit, the number of open files that can be opened by a user or a process. So admin user is allowed 1024, which is only like quite a low limit to begin with, but it's not something that should affect nginx. So we can just check how many files are currently opened by this admin user using lsoff, and we'll pipe it to wc-l. 691 files are open, which is well under the limit of 1024. Another way nginx could be limited by the number of files it opens is with the systemctl itself. So systemctl, we see the nginx configuration. It has a very less limit of 10 files. So basically across all master and worker processes, since nginx is a master worker architecture, it can only open 10, which is very less, and that's why it's failing to spawn a worker process. So what we'll do is, for the purpose of this challenge, for solving this, we'll just increase it to, let's say, 1000 files. But in a normal production scenario, it should be even like higher than that. But I think this will fix it. Since we changed a systemd unit, we need to do a daemon reload. Otherwise, our changes don't get picked up. Systemctl restart nginx curl localhost. We should see a default page. Yep. Yeah, that was correct. Nice. Let's move on to the 9th problem. this is about a Docker container which won't start. It's a Dockerized Node.js web application, and for the solution to be valid, there should be only one Docker container. Okay, makes sense. This is about the container not being spawned, I guess. So the issue could be in Dockerfile, Docker image, or even the Node.js application. And we have to get a container on port 8888. So yeah, there's not much hints about what could be wrong over here. So these are all just guesses while the server is being spawned. Once the server is spawned, the first step would be to create this container. So I'm guessing there would be a Docker image bundled in the server, and we have to run it. And we'll see after that what happens. I just wish it wouldn't take so much of time to spawn a EC2 instance every time this challenge comes, but that's okay. Yeah, so we are in the VM. We'll go to home admin. App folder has it. Okay, there's a Docker file that we need to create, I guess, because Docker images, the user is not there in Docker group. Okay, so there's an app image already created. I'm not sure whether, because that says 13 months. I mean, date time could be skewed in the server. Since a Docker file is already present, it's better if you just build it right now. Docker file dot, and we'll also tag it. We won't use app latest, we'll use app v1. So in any case, if we have to refer to the actual file, we can. We don't override it with our changes. Okay, that was fast. It's a pretty normal Docker file. Node.js images there. Then we have package.json, npm install. It's all cached. So it's running a command called nodeserve.js. So if we run exposed on port 8888 app v1, what happens? Okay, it says app address already in use. We can check what is running, because I think there's no Docker container which is running. Status is created. It's not exposing anything at all. The number of instances, which is number of Docker containers which is alive, I don't think there is anything like that. If we do docker ps, there's nothing running. So another way to check what is running on 8888, we can just grep for that in netstart. Oh, there's a nginx server which is running in this server, but this task doesn't talk anything about nginx. I am assuming it's safe to kill it, so we'll do that so that our Docker container can basically spawn. So I'll do a sudo kill -9, and killing the master process should be enough. So yeah, it's gone. Now we start it. Okay, it started, but we got an error saying cannot find module. I am not that familiar with Node, but cannot find module. When will that come? Let's take a look at what command it's actually running. It's running node server.js. Is node present here? Okay, it's difficult to check then. It's finding for a file user src app. So okay, user src app should be the work directory. serve.js should be a file inside it because we are actually copying everything. So you can check what all we have here. Okay, there's a typo over here, server.js and serve.js. Instead of editing, I can rename the file as well, but since we are just bundling it, building our own image, I think it's better if we fix the typo over here only. Then we'll just do a sudo docker build ourselves. Sudo docker build. And then we'll run sudo docker. It works. I think we can just check the solution. Yeah, this is correct. Nice. Oh, okay. So we're done with 9. We'll do, I think, 2 more. We'll close all other tabs. So this challenge is about whether the environment is a container or not, or it's a VM. This is a hard problem, I think, because okay, there are a few things that we can check here. One is the PID. Typically, PID1 is the most important process for any Docker container because that is from where you start any other process or any other executables. PID1 is what we have to inspect closely. And there are a bunch of things like VM will have a lot more processes running compared to a Docker container, but I'm guessing since this is a trick question, they would have emulated some behavior of a VM inside a container, if it's actually a container. First of all, we don't know that. It's a hypothesis to begin with, but let's work our way accordingly. What else can we check? We can take a look at C groups, but C groups exist in a normal VM as well. It's not a container specific behavior. Let's say check PSOX first. Right, so quite a less number of processes, but it's running journal D, dbus, daemon, which is what I believe is to confuse us, because these processes you don't typically run in a Docker container. But this is a PID1. It's been in it. I'm not sure what it is. Okay, it's basically a init thing. What we can do is, to find out more details about a PID1, we can go to the proc directory, proc /PID number 1. We'll have lots of different things. So we can access a bunch of different things over here, mount points, the C group. So first of all, that's what I want to expect. C group, what it says. This typically, as far as I know, means that this container, if it's a container, doesn't have any limit at all. CPU limits, it doesn't have. CPU quota, it doesn't have. Which is fine. It's not an issue. But what else can we check? We can check mount info. Mount info has something called as var lib containers. It could be to confuse people as well, but there are a bunch of container files over here. So I think it's indeed a container. What if I just search for Docker inside every directory? Yeah, this is a run Docker sock, right? So is that a Unix Docker socket or something related to a container? But if, okay, let's say I search for container. Yeah, the mount points have some information related to containers. Container storage overlay storage is being used in this particular thing, so I'm definitely inclined to think this is a container. But how do we test it? Is there a solution for that? Okay, there's no solution automated test for this. We can just have to open solution for this. We have to open this once again. Okay, this is a Podman container, and they also talk about PID1 process tree. And oh, the way to check this is by inspecting the environment variables. I never knew about this. It says that this should be container equal to Podman since it's a Podman container, but the author changed its value. So I still think this is all hit and trial because as the author says that they changed the value, maybe someone else can just remove that environment variable altogether. So there's no 100% foolproof way, but like we just made guesses by grepping the word container in the whole directory. We concluded it's a container. So I think similar stuff is being done here, but there's one more indicator which says that if there are no kernel threads in that thing. This is interesting. I think this I never knew about. This is like a TIL for me, K-thread. This was a nice challenge. I liked it. Learned something new. Okay, we'll do one last video, one last challenge, I think. So we have to close an open file. Some file is open for writing by some process. We have to close this file without killing the process. Okay. This I think is again tricky. Level of difficulty slowly ramping up with these challenges, which is nice to see. But yeah, let's see. So we have this file which is opened by some process. The best way to check is by lsoff command. So if you do lsoff this thing, we can see bash has opened it, right? So bash has loaded this file somewhere. We can take a look at bash rc maybe, if it is over there. Grep some file. Oh yeah, exec77. So exec is used to open or to close a file descriptor. That's what they have done. They have opened a file descriptor in the bash rc command with this ID, I guess. I don't know, but this is to redirect this operator is called a redirection operator. So this is what it means, and typically we use this when we have to redirect stdr output or std output to a common place in cron tabs or in cron jobs or some similar places like that. That's what I remember. So if you have to close this now, since bash has opened it, We can't kill bash because that's what the test is about. We can't kill bash, but we still have to kill. We have to close this file. Closing this file basically means you just close the file descriptor. That will close the file handle on by bash on that file. Closing the file descriptor can be done. I forgot the exact syntax, but I think it's an opposite command, but maybe this works. Yeah, it's something like this only. Okay, we have to Google this, I think. How to close a file descriptor. Close a file descriptor with exec. Oh yeah, I think our second or third attempt was correct, but we added a extra and over here. This is what we don't want here. This I think closed it. Let's check ls of we'll just grep it. ls of grep some file. Yeah, it's closed. Nice, that was correct. This was interesting, but this could have been more harder if that file descriptor wasn't present in the bash rc file, because here we could just check the file, but there can be ways to make this harder by hiding that where that file descriptor is opened from, where that particular instruction is coming from. But that was nice. We solved a couple of medium problems in this one, and I think in the next one we'll take on some hard problems as well. So stay tuned, and thanks for watching. Cheers.